With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on trigonometry. So here in this question we are given that we need to find all the values of theta between the 0 to pi range which satisfies the given equality. So here we are given the equality as the cos theta times of the cos 2 theta times of the cos 3 theta is equals to 1 by 4. So now we need to solve this theta for the values in between 0 to pi. So let us first consider this equality which is given to us here in this question. So here we are given that the cos theta times of the cos 2 theta times of the cos 3 theta is equals to 1 by 4. Now we are going to multiply this 4 from this denominator to this left hand side. So if we cross multiply it, then we get the 4 times of this thing, and it can be rewritten like the twice of cos theta. So here we have the twice of cos theta times of cos 3 theta. We are taking these two like this. And after this we also have 2 more left because it was 4. And we accumulate that 2 here with this cos 2 theta. So here we have the twice of cos 2 theta. So here we have the twice of cos 2 theta like this. And this would be equals to 1. Now for solving this side we are going to use one trigonometric identity. We know that the twice of cos x cos y. If we are given the twice of cos x cos y, then it would be equals to the cosine of x plus y plus the cosine of x minus y. So we are going to apply this identity. So let us say that if this is the equation 1, then by using this equation 1 here in these terms, we get the twice of cos theta cos 3 theta would be the cos of x plus y. So here we have the cosine of the x plus y, and x plus y would be the theta plus 3 theta. So here we have the theta plus 3 theta plus cos of x minus y. So here we have the plus cos of x minus y, and the x minus y would be the theta minus 3 theta. So here we have the theta minus 3 theta like this, and this is all multiplied with, here we have the twice of cos 2 theta. So here we have the twice of cos 2 theta, and that would be equals to 1. Now here we have the twice of cos 2 theta in multiplication with this term. So now we are going to multiply this twice of cos 2 theta inside this bracket. So if we do that, then here we get the twice of, and here we have the cos of theta minus 3 theta, which is the cos of minus 2 theta, and we know that the cosine of minus 5 is equals to cos 5. So here instead of the cosine of theta minus 3 theta, we will be going to write the cosine of 2 theta. So here we have the twice of cos 2 theta into cos 2 theta. So that would be the twice of cos square 2 theta like this. So we get the multiplication of this term with this term. And now we are going to multiply this with this first term. So here we have the twice of, here we have the plus sign with the twice of the cosine of, here we have the theta plus 3 theta, that is cos 4 theta. So here we have the cos 4 theta times of the cos 2 theta, and that would be equals to 1 here. Now we are going to subtract minus 1 in this complete equality. So if we do that, then here we get the twice of cos square 2 theta minus 1 plus here we have the twice of cos 4 theta times of the cos 2 theta, and that would be equals to 1 minus 1, that is 0. Now we are again going to use one more property of trigonometry. We know that the twice of cos square x minus 1 is given by the cos 2x. So this is the double angle formula which we are going to use here. So let us say that this is the equation 2. So now by using this equation 2 here, we are going to write these two first terms as the cos of 4 theta plus here we have the twice of cos 4 theta plus cos 2 theta, and that would be equals to 0. Now we are going to take this cos 4 theta common outside from these two terms. So if we take cos 4 theta common, then we get the cos 4 theta times of, inside we are left with the 1 plus twice of cos 2 theta, and that would be equals to 0. So here we are getting the multiplication of these two factors as equals to 0. So from this we can conclude that the first result would be the cos 4 theta is equals to 0, that is the first factor would be equals to 0. So this is the first result which we have got. And the second result would be the 1 plus twice of cos 2 theta would be equals to 0. So if we solve this, then we find the value of the cosine of 2 theta would be equals to the minus 1 by 2. So this is the second result which we have got. Now for solving this ahead, we are going to consider this third equation. So if we consider the third equation here, then here by using the third equation, we can say that here we have the cos 4 theta is equals to 0. And we know that the cos of theta is equals to 0, the cos of x is equal to 0 when the x is equals to pi by 2 or 3 pi by 2 in the intervals from 0 to 2 pi. So from that we can conclude that the 4 theta would be equals to, here we have the pi by 2 or the 3 pi by 2. And since the cosine is the function which repeats itself after the 2 pi cycle, then by using that we are going to add 2 pi into it, because that would also be the solution of this equation, because cosine is the repetitive function of 2 pi. So from that we get the 2 pi plus pi by 2. So here we get the 2 pi plus pi by 2, and from this if we add 2 pi to it, then we get the 2 pi plus 3 pi by 2. Similarly, if we add the 2 pi into it, then we get the 4 pi plus pi by 2. So here we get the 4 pi plus pi by 2. And if we add the 2 pi into this, then we get, here we get the 4 pi plus 3 pi by 2. Now if we add the 2 pi into it, then we get the 6 pi plus pi by 2. And if we add the 2 pi into it, then we get the 6 pi plus 3 pi by 2. Like this. Now we are going to solve this ahead. So from this we get the value of the 4 times of theta is equals to, here we have the pi by 2, here we have the 3 pi by 2. From here we get the 2 pi plus pi by 2, that is the 4 plus 1, that is 5 pi by 2. From here we get the 4 pi plus 3 pi, that is a 7 pi by 2. So from here we get the 7 pi by 2. From here we get the 8 pi plus pi, that is the 9 pi by 2. So here we have the 9 pi by 2. From this we get the 8 plus 3, that is 11. So here we get the 11 pi by 2. Like this. And this goes on up to infinity. So now we are going to find the value of theta. So from this we get the value of theta as the pi by 4 to the 8. From here we get the 3 pi by 8. From here we get the 5 pi by 8. From here we get the 7 pi by 8. From here we get the 9 pi by 8. And from here we get the 11 pi by 8. Like this. And this goes on up to infinity. Now since in the question they were asking about us to find the solutions in the interval 0 to pi. So we know that the 11 pi by 8 is greater than pi. So the solutions which we get after this would be greater than pi, definitely. So from this we get the solution of theta as the theta would be equals to, here we get the pi by 8. From here we get the 3 pi by 8, the 5 pi by 8, the 7 pi by 8, the 9 pi by 8. That's it. That is what we get from the third equation. That is this equation. Now after this we are going to consider the fourth equation. So let us say that this is the result 5 which we have got. Now we are going to consider the fourth equation. So in the fourth equation we have the cos 2 theta is equals to minus half. So by using the fourth equation we get, here we have the cos 2 theta is equals to minus half. So here we have the cosine of 2 theta is equals to minus half, like this. Now we know that the cosine of x is equals to minus half when it is the cosine function and it is negative, that is minus half. Then it would be in the second and the third quadrant. So it would be when the x is equals to, here we have in the second quadrant it would be the pi minus pi by 3. So here we have the pi minus pi by 3, and it would be the 2 pi by 3 on solving this. And in the fourth quadrant it would be positive, but in the third quadrant it would be negative. So the second value of x would be the pi plus pi by 3. So it would be the pi plus pi by 3, that is the 4 pi by 3. So this is the solution of x which we have got in the interval 0 to pi. So here our x is 2 theta, so from this we get that 2 theta is equals to, here we have the 2 pi by 3, here we have the 4 pi by 3, like this. Now since we know that again cosine is a repetitive function in the interval of 2 pi, so we are going to add the 2 pi to its solution. So here we have the 2 pi by 3, so if we add 2 pi then we get the 2 pi plus 2 pi by 3, like this. And if we add 2 pi to it we get the 4 pi by 3 plus 2 pi. So here we have the 2 pi plus 4 pi by 3, like this. Now if we add 2 pi to it we get the 4 pi plus 2 pi by 3, like this. And similarly if we add 2 pi to it we get the 4 pi plus 4 pi by 3, like this. And this goes on up to infinity. So now we are going to solve it here. So if we solve this we get the value of the 2 theta as the 2 pi by 3 and the 4 pi by 3, like this. If we solve this and we get the 3 2s are 6 plus 2, that is 8 pi by 3. So from here we get the 8 pi by 3, and from here we get the 6 plus 4, that is a 10 pi by 3. From here we get the 12 plus 2, that is 14 pi by 3. And from here we get the 4 3s are 12 plus 4, that is a 16 pi by 3. So here we get the 16 pi by 3. And it goes on up to infinity, like this. So now from this we can find the value of theta. So here we get the value of theta as the theta would be the pi by 3, the 2 pi by 3, the 4 pi by 3. Here we get the 5 pi by 3, the 7 pi by 3, and the 8 pi by 3, like this, and so on. Now we can clearly see that from here these solutions are greater than pi, so they will be useless. So from this second result we only get the value of theta as the pi by 3 and the 2 pi by 3. That's it. So this is the second result which we have got. So let us say that this is the equation number 6. Now we are going to conclude that what is our final result by using the equation number 5 and the equation number 6. And here in this fifth result we also got the 9 pi by 8, which is also greater than pi. So we are also going to reject this final one. So we have this as a solution. Now we are going to write our final solution. So that would be, here we have the pi by 8. So the theta would be the common union of the fifth and the sixth equation. That is, the first result is the pi by 8. Then after pi by 8 we have the pi by 3. So here we have the pi by 3. Then we have this 3 pi by 8 here. So here we have the 3 pi by 8 included in our solution set. Then after 3 pi by 8 we also have our 5 pi by 8 here. So here we have the 5 pi by 8 also in our solution set. After 5 pi by 8 we have this 2 pi by 3. So here we have the 2 pi by 3. Then after this we have the 7 pi by 8. So this is our last solution which we have got. So here we have the 7 pi by 8. So we have got these many values of theta belonging in the interval of 0 to pi. So in the question they asked us to find all the values of theta which belong in the interval of 0 to pi. And here we have got all the values of theta which belongs to the interval 0 to pi. So this is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.